This is the Sunday solution video for the review that I gave you for Sunday. We've done quite a few graphing inequalities. So rather than spending the time graphing this, I went ahead and put the solution up here. It's extremely important to note that this line is a dotted line, okay? And the reason it's dotted is because this inequality is just less than, okay? This one here is a solid line, and my solution set, which they said label with an S, is any points in this kind of area right here. And again, I found that just from using my calculator. Now, the question is, Allison thinks that -2 or 2 -9 is the solution. Determine if Allison is correct, justify your answer. So justification could be a calculation. So if you wanted to substitute 2 -9 into both of the inequalities and show that it makes the top inequality false, that would be an appropriate justification. You can also use sentences to explain or justify your answer. Justification does not require a sentence, but you can use a sentence. So make sure you answer the question. So the question is, determine if Allison is correct. This is not a yes or no question. This is she correct? So I said Allison is incorrect because the point 2 -9 is on a dotted line. And so it is not a part of the solution set. So you want to specify how you determined that. So again, you could plug the point in and show it makes the top inequality false, or you can write a sentence and explain how you knew based on your graph. Lydia wants to take art classes. She compares the cost at 2 art centers. Center A charges $25 per hour and a registration fee of $25. Center B charges $15 per hour and a registration fee of $75. It says, write an equation that models the situation where A represents the total cost of center A. When in doubt, set up a table. So if Lydia does not go to center A's classes at all, she's still going to have to pay the registration fee when she signs up. But then for each class, it's going to be an additional $25 per hour. So for center A, my equation would be y equals, I'm starting at 25, and then I'm adding 25 over and over again, so it's 25 times x. Write an equation that models B. So again, I'm going to be very careful here. If she does not go to any classes, she's still going to have to pay $75 when she registers. And then it's going to be an additional $15 an hour. So my equation for center B would be 75 plus 15x. Now, I just happened to notice, because I always go back and reread the problem, it says here, A represents the total cost. So I actually think I can't use y equals. I have to use A equals. And then I want to make sure X is okay. It says X hours of classes. So that is okay. Down here, I need to use B equals. If Lydia wants to take 10 hours of classes, use your equations to determine which center will cost less. So 10 hours. And again, you do not need to show all these calculations. You can just type this into the calculator. And A is 275. So now, if she wants to take 10 hours of classes, use your equation to determine which center will cost less. B will cost less. Graph the equations for center A and center B on the set of axes. So center A starts at $25. I'm counting by fives here. So I know my next point is going to be 150. So I'm going to go over 1 up 50. Then it's 275. So now I can start to notice my pattern here. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. I'm going to plot every point I can. Ooh, you know what? Well, it doesn't tell me she can't do a partial hour. So you know what? I'm going to connect these. At first I was thinking maybe I wouldn't connect them, but it just says $25 per hour, and it doesn't say anything like she must take a complete hour of class. Okay, B. B is starting at 75 and then only doing at 1, it's 90. So I'm going up 3 over 1. At the bottom, it says state the number of hours of classes when the centers will cost the same. State the number of hours. So if I look at my intersection, my number of hours is 5 hours. It doesn't ask me what the cost will be. It just says state the number of hours. It doesn't ask me to justify, so I don't have to worry about like providing any kind of calculation. And I'm done. Mike uses the equation B equals 1300 times 2.65 to the x to determine the growth of bacteria in a laboratory setting. The exponent represents. So let's talk about what each of these is. 1300, this is the initial number of bacteria when x is 0. 2.65 is 265%, which is, remember, we always start with 100% plus 165%. So the bacteria increase by 165%. So that's our growth rate. And then X would be the number, sorry, the number of times we multiply by 2.65. That's the number of time periods. The total number of bacteria currently present is the result. That's B. The percent at which the bacteria is growing is 165%. And the initial amount of bacteria is 1,300. So knowing what all those are is important because they could have asked you for any of those values. 38, which function will have the greatest value when x equals 1? When we see functions, we're going to graph them. So I'm going to start with 2 times 5 to the x. I'll do menu trace, graph trace, and I'll go to 1. And that g of x is going to be 10. Number 2, I'll go up and delete that. 2 is 2x plus 5. At 1, it's 7. 3. 3 is 2x squared plus 5. So at 1, it is also 7. And then the last one is 2x cubed plus 5. And at 1, it is also 7. So which one has the greatest value? It's number 1. 39, when completing the square, which equation is a correct step? So I've got x squared minus 18x plus 77 equals 0. When I complete the square, my x's need to be on one side and my numbers need to be on the other. So I've got to subtract 77 from both sides. Then when we complete the square, this is the step everyone kind of forgets. They get stuck at this point. Remember, we need to add something. So I'm going to set up a square, and I'm going to use the two things I've got to create a perfect square, which means negative 9x's have to go here and here. Negative 9 and negative 9 is 81. So what am I going to add to both sides? Well, it's going to be 81. None of these so far look like the answers I've got up here. The left side factors into x minus 9 squared, and negative 77 plus 81, I believe, is 4. Does that show up anywhere yet? Oop, it does. Here's a correct step in the process. Now, if I were to keep going, I'd have to square root both sides. So I get x minus 9 equals plus or minus 2. I could add 9 to both sides. No, I couldn't. At this point, I'd have to set up my two equations and solve. But I already found my answer. It was answer choice 1. The 24th term of this sequence is what? So I got to figure out what type of sequence this is. To go from negative 5 to negative 11, I could subtract 6. And then negative 11 minus 6 is negative 17. And I can keep doing this. It's really important to remember this is my first term, second term, third term, fourth term. So I'm going to go ahead and write an equation for this. I'm starting at negative 5, and then I'm subtracting 6 over and over again. But since I'm starting at my first term, I have to subtract 1 from my variable. And now to get the 24th term, I'm just going to replace n with 24. And again, I am not going to try to do this outside of my calculator. Or if I do, I'm going to definitely check it with my calculator because there's a lot of places you can make a careless calculation error. And I get negative 143. What's interesting is if you forget to subtract 1, you will get negative 149, which is here. That is definitely a trap answer. Okay, the expression is equivalent to. Equivalent means same graph. Again, we're trying to minimize careless errors. So I'm going to type in the original problem. And nothing shows up. So let me go to menu, trace, graph trace. And now I can start to see my graph is way up at the top. So I'm maybe going to extend this to 20 so I can see a little bit further up there. For the sake of time, I don't want to go through and type all these answers in. What I'm going to do instead is I'm going to solve it algebraically and then check it with my graph. So in front of this set of parentheses is a 1. So I would distribute that and I would get 5x squared minus x plus 4. In front of this set of parentheses is a negative 3. So I would get minus 3x squared plus 3x plus 6. Then I can combine my like terms. 5 minus 3 is 2x squared. Negative x plus 3x would be plus 2x. And then 4 plus 6 would be plus 10. So I think it's answer choice 2. I'm going to verify that by graphing it. And I can see its equivalent. So I feel very good about that. Which linear equation represents a line that passes through the point -3, -8? So I'm going to graph each of these. So I've got 2x minus 2, and I can graph it as a regular function because y is by itself. And I'm going to go ahead and type -3 in. Oh, look at that. Answer choice 1. Now, just to make sure, I'm going to go ahead and I'm going to change this last one to answer choice 2. If I go menu, trace, graph, trace, and type in -3, I can see it doesn't go through -3, -8, and so on. Solve for x to the nearest 10th. Remember, if you're solving a quadratic to the nearest 10th, you are most likely looking for irrational answers, which means quadratic formula. It's equal to 0, so I'm good to go. A is 1, B is 1, and C is -5. You're going to take out your reference sheet and you're going to copy down the quadratic formula. And then you're going to store your values. So 1 is going to be stored as A. 1 is going to be stored as B. And then -5 is going to be stored as C. So now I'm going to type in -B, and I get -1. Keep the square root. B squared minus 4AC. And Trevor would remind me I've got a multiplication there. Over 2A would be 2. Now, I'm not going to reduce this. It says rounded to the nearest 10th. 10 has 1 0 in it, so that's 1 decimal place. So my first answer is -1 plus the square root of 21 over 2. My second answer is -1 minus the square root of 21 over 2. And now I'll go ahead and put this into my calculator. -1 plus the square root of 21, over 2 gives me 1.79. Rounding, that's the 9's going to bump the 7 up to an 8, so 1.8. And then my second one is -1 minus the square root of 21 over 2. And that's -2.79, but the 9 is going to bump the 7 up to an 8. And there's my 2 answers. 44, the graph of the function p of x is represented below. On the same set of axes, sketch the function p of x plus 2. So if you have a function p of x, if we add something to x inside the parentheses, it is going to shift the function left or right. left or right. But it goes in the opposite direction. Because this is a plus 2, it is going to shift the function left 2. So this vertex is going to move left 2. This root is going to move left 2. This root is going to move left 2. And if I could find some other good points, I can move those over as well. And then I'm going to connect them. So there's my function p of x plus 2. Don't forget to sign the line. Now, let's say they asked us to graph p of x plus 1. This is not inside the parentheses. This is outside the parentheses. So this is going to shift the function up 1. So my function would look something like this. If they asked me to graph p of x plus 1, where the plus 1 was outside. When an apple is dropped from a tower 256 feet high, the function h of t equals negative 16t squared plus 256 models the height of the apple after t seconds. Determine algebraically the number of seconds it takes the apple to hit the ground. Well, if it's on the ground, the height is 0. So I need to algebraically solve this equation. Because there's only one t, it's squared, but there's no like 18t in there. I'm going to subtract 256 from both sides. Then I'm going to divide both sides by negative 16. And I get 16 equals t squared. Then I can square root both sides. Whoops. And I get t equals plus or minus 4. Well, if I'm dealing with a situation where I'm dropping an apple, okay, then I'm not going to deal with negative time. T is going to be 4 seconds. Now, I can verify this by graphing this. So I've got negative 16x squared plus 256. Here's what it looks like. 256 is my highest point that my apple is at. So I'm going to make my y-axis go to 260. Here I can see it. It's dropped. It comes down and it hits the ground. If I go menu, trace, graph, trace, my 0 occurs at 4. Okay. Is the product, you must know product means multiply, of radical 16 times 4/7 rational or irrational? Explain your answer. I'm going to multiply this right in the calculator. Square root of 16 times 4/7. And what I get is 16 over 7. If I hit Control Enter, I will get this long decimal. But if you notice, if I come up and grab this, okay, 1, 4, 2, 8, 5, 7, 1, 4. This is actually a repeating decimal. It's 2.28571. Oh, my 4 didn't stay. 4. And that keeps repeating over and over again. If the result is spit out as a fraction in your calculator, it is rational. So in this case, I would say it's rational because the product is a fraction. And as long as it's a fraction where the top and the bottom are whole numbers, it's a rational number. On the set of axes below, graph the piecewise function. So I'm going to start with this first piece. It's telling me I'm graphing this for x's below 2. So numbers below 2 would be 0, 1, 2. Because this doesn't include 2, I need an open circle here. And since it's below 2, I'm going to keep going. I'm going to do a graph so I can see what this looks like. Negative 1/2 x. Enter. Menu, trace, graph trace. And I'll start at 0. At 0, my function is 0. At 1, my function is negative 0.5. And at 2, my function is negative 1. So I'm at 0, 0, 1, negative 0.5, and 2, negative 1. That needs to be an open circle. Now, I do need to keep going to the left. So let me see where it is at negative 1. I don't want to graph that. Let me do negative 2. So at negative 2, it's at 1. And I can keep going. There's what that piece looks like. My next piece is for x is greater than or equal to 2. So now here is where 2 is included. I'm going to open a new graph. So I'm going to start at 2. It's at 2, 2. 3 is at 3. 4 is at 4, and so on. So 2, 2 is here. It's a closed circle. And then it goes off in this direction forever and ever and ever. Okay. Excuse me. Any other questions here? No. So we just had to graph it. Now remember, I can verify this in my calculator. If I press the button next to the 9, here's a piecewise function. And then x for x greater than or equal to 2. And if I had entered, that's what it looks like. That looks exactly like what I have. Okay, that's the end of our Sunday video. A lot of good review there. So, yeah, one more day of review and you guys are on to take this test.